Now let us discuss the 9-1 question. Which of the following molecules is non-polar in nature? Here they are asking that among the 4 options, which is belonging to the non-polar molecule. Now let us try to understand what do you mean by non-polar. According to dipole momentum, which molecules have the dipole momentum that is mu equal to 0? These are called the non-polar molecules. That means mu not equal to 0. That molecules are called the polar molecules. You can also define polar and non-polar according to electronegativity. If the electronegativity difference, that means now for suppose A bond B, this having the electronegativity of 2.2 and B element having the electronegativity of 3.3. Its difference is 3.3 minus 2.2. Its difference is 1.1, which is greater than 0.5. These are called the polar bonds. These are polar. And if electronegativity difference is less than 0.5, then it is called the non-polar. The most of this type of questions you can easily solve by draw its structures. Now let us draw the each and every structures of given options. First one, in NO2 there is a presence of odd electron. Now let us try to draw its structure. N double bond O and bond N bond O, it's an coordinate bond. It is having one odd electron. Its direction upwards. And how to balance here oxygen. Here 2 electrons involved in this. 2, 1, 2, 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Okay. The odd electron is its direction is upward side. Here the 2 oxygens have different dipole momentum. That's why the net dipole momentum, which is not equal to 0. Why? Because they have different directions. In this, 2 oxygens having different dipole momentum and odd electron having the different direction of dipole momentum. That's why the net dipole momentum, which is not equal to 0. That means this is a polar molecule. That means POCl3. P double bond O, Cl, Cl and Cl. We know that chlorine have a higher electronegativity than phosphorus, then its dipole momentums are in this way. Here oxygen having higher electronegativity than phosphorus, the dipole momentum direction is upward side. Here the net resultant, dipole momentum, which is not equal to 0. Why? Because you can cancel 1 and 1. Here 2 are present which are not equal to 0. That's why it's a net dipole momentum which is not equal to 0. Thus, thereby you conclude that this is an polar molecule. Now verify the option 3. CH2 bond O. This is called formaldehyde bond hydrogen, C double bond O bond hydrogen. We know that oxygen having higher electronegativity than carbon, its direction is upward, and here carbon having higher electronegativity than hydrogens. That's why its direction towards the hydrogens. Here also the resultant net dipole momentum does not cancel to each other. That's why the resultant dipole momentum, which is not equal to 0. This molecule also polar in nature. Now let us verify the fourth one. SbCl5. Its structure is similar to PCl5. PCl5 has trigonal bipyramidal. Here Sb, Cl, 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 Cl. These 2 chlorine atoms are in axial position and the remaining these 3 are in equatorial. This we know that chlorine is a higher electronegativity than Sb, then its direction will be in this side. Here, axial cancel and equatorial dipole moments are cancelled to each other. That's why the resultant dipole moment here mu equal to 0. Why? Because here axial and equatorial cancel to each other. That's why it's a dipole momentum. The resultant dipole momentum mu equal to 0. That's why this molecule is non-polar in nature. So 4 is our correct answer.